Next question asked in 2016's exam. So the question says triangle ABC is right angled at C. Okay, so ABC is a right angle triangle. If P is the length of perpendicular from C to AB and ABC are length of the sides opposite to angle A, angle B and angle C respectively, then prove that 1 by P square is equal to 1 by A square plus 1 by B square. Okay, so again, since it is a right angle triangle and there are square of the sides, so it is a question from Pythagoras theorem. Let us first of all write down what is given. So it says triangle ABC is a right angled triangle, right? Further, the sides A, B and C, and your prove that is 1 by P square is equal to 1 by A square plus 1 by B square. Okay, so if I want 1 by P square, 1 by A square and 1 by B square, exactly what I have to do? See, even though here we are making use of the Pythagoras theorem, but as you can see, the square of the sides are present in the denominator. They are not present in the numerator. So directly if you frame equations of P square, A square and B square, you will not be able to simplify it, isn't it? So we have to think a little beyond and see exactly what could be done so that we can get the values in the denominator. Okay, so first of all I will be applying the Pythagoras theorem in the outer triangle, the bigger triangle ACB, and let us see what equation we get. So in triangle ABC by Pythagoras theorem, I can write C square is equal to A square plus B square, right? Now I want 1 by A square and 1 by B square. So if here I want 1 by A square or here 1 by B square, what if I divide this equation by A square B square, so that A square will get cancelled and I will get B square. Similarly, this also side, if I divide it with A square B square, again B square will get cancelled and I will get 1 by A square. And here instead of C square, I will be wanting 1 by P square. So what can be done so as to obtain an relation between the all four lengths, that is P, A, B and C? If you find a relation between all the four lengths, then definitely you can replace them and get the obtained proof. Okay, so what could be done? What if I apply the area of triangle formula for the same triangle but considering two different bases? Meaning in first case I will consider base as A, so its height would be B, and in second case I will consider C as the base, so its height would be P. So the area is of the same triangle, so I can equate the two equations, isn't it? So let us write area of triangle ABC is half into, I am taking base as A, so height will be B. And in second case, the same area of triangle ABC, but here my base will be C and the height falling on that base is P. Okay, so this is your equation 1 and this is your equation 2. So now as you can see, the both are areas of the same triangle. So definitely if their LHS are equal, their RHS will be also equal. So can I write half AB equal to half PC? Reason you can specify from 1 and 2. So this half will get cancelled. So what you are getting? You are getting AB is equal to PC, isn't it? So that is what I want. I want all the four sides into one equation. So I want a relation between them. Now here I want to replace this C with some another value, because in our proof that C is not present, P is present, isn't it? Okay, So what if I write C equal to AB by P, shifting this P to other side. Again I want C square. So I will write, taking square, C square is equal to A square B square by P square. Okay. So let us replace here. If I make this as equation A, because I have taken 1 and 2 here. So replacing value of C square in A. So instead of C square, now I will write A square B square by P square equal to A square plus B square. Now as I have said, if I am able to divide this side by A square B square, I will get my RHS. So now I cannot divide just the right hand side, I have to divide the left hand side also. So I can say dividing both sides by A square B square. Dividing both sides by A square B square. So what you will get in the LHS, this A square B square and the A square B square in the denominator, they will get cancelled. So you will get only 1 by P square equal to here A square upon A square B square plus B square upon A square B square. So A square cancel, B square. Now can I cancel them out? Yes, because they are into division in their own term. Yes. So 1 by P square is equal to, I want A square term first, so I will write it first, whereas B square term second, so I will write it second. So this is your equation that is to be proved. Very easy. Just we have applied the Pythagoras in the outer triangle, and then we have obtained one relation between all the four sides by taking the areas of the triangle. Yes, the area of the same triangle but with two different bases. Now since the areas are of the same triangle, so I have just equated them, and hence I have obtained the relation C is equal to AB by P. And since I want C square, I have taken square and then I have replaced that in the equation A, and just by simplification I have obtained the required proof.